Hi, everyone. Thank you so much for joining. We will give it just a couple of minutes before we get started to let a few other people join. See a lot of familiar names from our previous events and the SafeGraph community, which is very exciting. All right, good afternoon, everyone. Thank you again for joining today's session. I have a few opening items before we get started with James, so I'll go ahead and get started. Just a quick introduction for those that I haven't met previously. My name is Nikki Kazahaya, one of the community managers here at SafeGraph. If you'd like to join, or if you'd like to invite your peers and colleagues to the SafeGraph community, I will post a link to join in the chat. It's a free Slack community for data enthusiasts. You get access to our support team, research sharing opportunities, and get to connect with others in the data science community. So moving forward, we will also ask that community members join the community to get access to our event programming as well. So if anyone is also new to SafeGraph and feels that they would benefit from a short onboarding call, I'm certainly happy to get that on the calendar. We'll go over how to download your first data set and get you oriented with some of the resources that we have here at SafeGraph. So in a few minutes, I will drop my email address in the chat. I'm also very active on Slack as well, so feel free to reach out to me on either platform. So just an icebreaker to get things started. I'm curious to hear, and you can enter your answer in the chat. So how many people on this call today attended our previous Knowledge Series event, which was our first event with Eugene Chong from our SafeGraph team? So I'll let the answers kind of file in. Also, just a few other things to keep on your radar. If you find today's session, our Knowledge Series, useful, we do have another Knowledge Series event coming up that I want to keep on everyone's radar. Dr. Jeff Ho with the SafeGraph product team will go over some best practices for working with time series data. We're still finalizing those details, so for everyone attending today, we'll be sure to follow up with an email on those details. However, if you're looking for another event that we're hosting that's coming up a little quicker, certainly recommend joining our fireside chat with David Rothschild, an economist at Microsoft Research. So that'll be happening on August 13th at 1 p.m. Pacific. I'll also drop the link for that here in a few minutes. For those that are new to some of our SafeGraph event programming, go over just a few of the ground rules. So we want to make sure everyone in this session walks away with some valuable takeaways, regardless of background and experience. So as James starts in on his presentation, should you have any questions, don't feel obligated to wait till the very end. We're certainly happy to take questions as they come up. You're welcome to post them in the chat, raise your hand, or throw them in the Q&A box. I'll try to keep an eye on that one. So as they come in, I'll ask that if you feel comfortable, turn on your audio and your video, and we'd love to have you ask your question live. So at this point, I'll go ahead and introduce our guest speaker today, James. James is a software engineer at SafeGraph, working on machine learning and AI for the Patterns product. Prior to SafeGraph, James held senior engineering positions at Uber, AT&T, and UCLA, and has over 20 years of industry experience. So thank you so much for joining today, James. I will pass things off to you.
All right, thank you, Nikki, for the introduction. Today we're going to be talking about best practices for working with large data sets. Let me share my screen real quick. All right. And yeah, so here at SafeGraph, we're going to talk a little bit about what I do here at SafeGraph, the kind of data that we work with, and maybe a little bit about some of the data that I worked with in the past. The most recent position before this was at Uber. I was the TL for the streaming ecosystem, which is a big word for the Kafka infrastructure there. We processed about 3 trillion events per day for Uber. And here at SafeGraph, we mostly work with movement and location data. And our main product is the Patterns product, which is sort of aggregated movement statistics across the US and Canada. And we also offer a very rich POI data set that covers the UK as well. So on today's agenda, first we're going to talk about the nature of the data that we work with, just to give an idea of, what our constraints are and what our workflows are. We're going to talk about some of the things that really impact, that are very significantly impacted by big data workflows, like the development velocity. How can you quickly iterate on new data coming in? How can you, get your developers, your data scientists and analysts moving quickly and introducing new features and changes into your product? We're going to talk about data quality, why it's important, and how we can ensure that we have data quality even while maintaining data workflows that can span many hours or days or weeks. And we're going to talk about failure recovery and the importance of that. And one, how we can ensure it, how we can quickly recover from failures when moving large amounts of data, and why that is important and how it impacts both velocity and quality as well. So here's what we do. We process about 2 billion rows of location data per day. This comes out to about 200 gigabytes of new data per day. And we use this in order to create aggregated statistics in different windows of time. One of our main products is the weekly patterns product, and it requires 2 terabytes of this data in order to produce that patterns product, and about 25 hours of total compute time spread out over the course of about 9 days. We also have a monthly product, very similar to weekly, but on a monthly window of time. That takes approximately 6.4 terabytes of total data and requires an aggregate of 104, give or take, hours of compute time. This isn't in addition to the weekly. We sort of leverage that weekly work in order to build the monthly. And we merge in over 8 million POI metadata and information geometries spanning the US, Canada, and the UK. We also have some other products, Natterns, but these are the big ones that take a significant amount of information. Natterns is neighborhood patterns, our internal term for it. What this amounts to is about 300 terabytes of production critical data that we've collected over the last several years that we've been in business. And we also do a biannual backfill, where we take all our most recent data and recompute everything over the data set. So there are biannual work where we have to manage and mitigate failures across the processing of hundreds of terabytes of data. So development velocity. What I'm kind of referring to here is like, how fast can your data scientists, your analysts, and developers see the results of their efforts in the code? How can they quickly iterate on the failures that they make in bugs in order to produce the product that they want or the outcome that they want? The problem here is that long iteration times are sort of the bane of many a big data shop. And if you've worked in big data before, or worked with very large data sets, I am sure you heard the tales of people like making one little change, kicking off a pipeline, and then waiting for many, many, many hours before they even find out if what they did was a viable change or something that they wanted, or possibly even getting an error and the whole pipeline fails and they have to restart again after debugging. So one of the key ways that you can sort of increase the velocity of your developers is through taking small samples of your data for development work. And you can do this incrementally as you ingest the very large data sets. And we're going to have a little architecture diagram we can look at later. Sampling is a kind of a deep topic, and there's a lot of different ways to do it. You could probably do a whole talk on it. But the key here is mostly that it be representative of your main data set. And the main objective is that they can run their code, and all those low-hanging errors like typos and things like that can be debugged very quickly with a representative data set. Another key is to keep metadata about both your data sources and your model parameters. And there's a lot of different ways you can do this, but you have to think like, for example, as I mentioned, we go back as much as 3 years in order to recompute data. So you have to have like the context in which that data was gathered, any quirks about it, notes on it, so that you can adjust and maintain your data consistently, even if you go back and recompute. As far as keeping like model parameters, there's a lot of different tools to do that. Here at SafeGraph, we use MLflow. At Uber, there was internal tooling that was built. There's also a few other libraries out there you can do with. The key isn't necessarily what specifically you use, but that you should have some kind of system which you can go roll back the changes you made to your model and sort of rerun using a previous version or iterate in the version. And finally, you should automate as much as possible. Ideally, the workflow that your developers have is simply writing code and kicking off a job and getting back results and viewing the visualization. So data quality. Now, garbage in, garbage out. I'm sure we've all heard that. You got to make sure that the data that you're feeding into the system is of a quality that conforms to your expectations and doesn't have values that will, throw kinks in your system. And the way that you should approach data quality is if you can decompose your pipeline such that a unit of significant work always has a data quality check after. So anytime that and what that time frame is can vary depending on the criticality of your deliverables, how tight your window is and what cadence you have to maintain. So you want to focus on inflection points, which means that say you have an ingestion stage, you're doing some data cleaning and some transforming. As soon as you're done with that, you want to do a data quality check to make sure that your schemas are valid and that you don't have any nulls where you don't expect them, that your columns are conforming to particular values and data types. Then, so right here we go down the key things that you should be checking. So, schema is a very easy one to do. Just make sure the columns are there that you expect, that they're of the types that you expect. Enforce column constraints. If you're not supposed to have nulls, check for that. You should treat it kind of like a unit testing for your data set. And there are a couple of frameworks out there that can facilitate exactly this kind of declarative pattern. One of them that we've begun to use here is called DQ, that has come out of the Amazon Labs group. It supports, it has libraries in Scala and Python. And there's also Great Expectations, which is mainly Python based. If you're in TensorFlow, TensorFlow has TFDV, which is the TensorFlow data validation. Again, a lot of different technologies to do this, but the key is that at each significant mode of work, you're enforcing these data quality constraints on your work. So finally, once you've done that data quality check, create a snapshot. Storage relative to compute is usually cheaper, except in very long term. So after you've done a whole bunch of work on your compute resources, you validated the quality and you're getting ready to move on to the next stage, go ahead and store that out. Again, there's a few ways to do this. So when do you create your checkpoints? So you have to ask yourself questions about your data flow. How time sensitive is your delivery? How show-stopping would a failure be if you had to recompute everything? You want to ensure transactional consistency every time you take a checkpoint, so you don't have like a halfway right. And the checkpoint ensures that you've decoupled the different stages of your pipeline. The way that it's decoupled is if you do have a failure or you need to go back and only do one leg, then you're able to reuse that existing data instead of restarting from the beginning. Ideally, you'll also have a way that you can detect, failed jobs or jobs that get stuck. You can kill them and restart from the previous check. So, some of the technologies that we've worked with to do versioning or do checkpointing, there's just good old like Spark write and then reread to particular directory output that you internally set. There's also Delta Lakes, which allows you to take like a differential version of the tables that's come out of the Databricks group. There's I've run into Pachyderm, and there's a new sort of differential snapshot framework that's come out called LakeFS. I haven't worked with it yet, but it looks very promising. So here's kind of like an architecture of what that might look like. And so you can see that you have, a very typical data pipelining work that you've done. You have your ingestion stage, data flowing into that. As soon as your data comes in, you want to be doing, schema checks and validation across that. And you do your cleaning, your transforming, mapping into a consistent schema that the rest of the next stage of the pipeline is expecting. And as soon as you get done with that, you do a data quality check, and then you do a checkpoint. You sample from your checkpoints, and you pass along to the next stage. And this can be chained on as much or as little as you need in order to produce your product. Your data scientists, analysts, and developers can sort of work outside of this system by simply accessing the data samples that are pulled from, validated, checked data at any stage, depending on what leg of the particular pipeline that they're working on. So, I mean, this kind of puts together what a good solid workflow would be. Again, when you do these checkpoints, when you do your data quality checks, depends on your time constraint. So, for example, if you have a product that you're delivering every 24 hours and you have a 12-hour pipeline, it might make a lot of sense to be pretty aggressive with your checkpointing and data quality checks. You might do it every hour or even every 30 minutes, depending. However, if you have something that sort of has a daily compute aggregated over a week and you have a few days in order to deliver it, maybe a daily checkpoint and daily aggregation would be sufficient. But the key is that you should be able to revert back and start your pipeline from any one of these points, thus reducing the footprint or the impact of having to process like the entirety of your original data. And ideally, your samples can fit into whatever the workstation environment is of your day-to-day developers and data scientists. So that is how we've been managing, or we are moving towards managing our data pipelines here at SafeGraph. I guess we can open up to questions if you'd like to talk about any of the specific methods that we use to address these pain points.
Awesome. Thanks, James. We'll give everyone a couple of minutes for the questions to come in. While we do that, let me drop some of this information that I mentioned. While we wait, I have a couple to at least kind of start the conversation. So obviously this conversation is all about best practices, but maybe what's something that's possibly a little bit counterintuitive that you or your team utilize?
A little counterintuitive. No, that's a counterintuitive. I mean, most of the solutions that we use are fairly, fairly straight shots at this. It's just iterations
Gotcha.
over, optimizing what you're doing. Looking at we use a lot of Spark internally, and so there's a lot of looking at your graph output for Spark, sort of tuning your data. Well, I guess one thing that might be unintuitive at first glance is the partitioning problem. I've run into this both in streaming applications, say in Kafka, and also we just had a body of work that was done here by one of our engineers that one of the big solutions was on the partitioning problem. So if, when you're in a distributed system and you're trying to shard out your workload in order to, utilize a lot of different resources, generally people are grouping or joining on particular keys of data. An example might be I have data across the US, and so I'm going to group all the states in order to do a computation. And the partitioning problem is that you might have a much greater density of your data, localized to a particular one of those partitions. And if that occurs, even though you've distributed across a very large cluster, you'll have one of your clusters that is basically maxed out and having to do the bulk of the computation load. The intuitive way to connect this would be like, well, California is going to have way more movement data than a more sparse state in the Midwest. And so if you were grouping by states, you might have one machine doing all the work for California while all the other machines wait. In Kafka, we would see the same sort of thing where you might have one one producer or one consumer that was responsible for the bulk of the information that was being put into the system. So it's always important to pay attention to like how you're slicing your data up and how you're distributing it across your system and making sure it's utilizing all of the resources you put in.
Sure, sure. Actually, we just had a couple other questions come in. So Ite, if I will allow you to talk if you'd like to ask your question.
Let's see. I wonder about how confident.
Ite, if you could unmute.
Yeah.
Or I guess the question is coming up on your end as well, James, if you want to just go ahead for it.
Yeah, so I'm seeing a couple of things here. I see, please give me tips for generating or engineering features and interview an industry professional example or using tacit knowledge. Feature engineering is definitely, a lot art and a lot comes with just the experience and a deep knowledge of the data set. And that's where domain experts come into play and why they're so valuable. You said, should I interview an industry professional? I would say that if you don't have that deep domain knowledge of your data set, then consulting with someone who does is definitely essential to coming up with good features for it. If you have like a lot of features, like you have hundreds of features and you're trying to narrow down which ones are the most important, there are some techniques you can use by looking at information gain across different columns, looking for correlation between different columns so that if two of the features are highly correlated, usually you can drop one for the most impactful. You can also aggregate across the columns if they're very disjointed. It's sort of like taking the product of one column and the other. But yeah, feature engineering is like a pretty deep topic. And again, there's a lot of art involved. So domain expertise is definitely a must.
Ite, hopefully that answers your question. Certainly feel free to follow up in the chat or in the Q&A if you have any other follow-ups. One other thing, so where can we send our attendees if they're wanting to learn more about this topic? Are there helpful resources that you'd like to refer to or other platforms that you like to frequent?
Yeah, I think the Databricks documentation is actually quite good, particularly for the things that they offer. They have the Delta Lakes, which again is sort of data set versioning. It's a very low resource way that you can sort of take snapshots of different iterations on your data. It's an open source project, so you're not bound to the Databricks ecosystem to use it. They have very good documentation on it, and I think that it explains the use cases and motivations for why you would want to do that very well. The ML flow documentation, which I think particularly within the Python world is sort of a de facto standard for model versioning and being able to take versions and snapshots of your entire experiment that you've done. So this includes referencing like the data set you've used, the features that went into the model, the particular tuning variables and hyperparameters that were set for the model. And then it's able to save this all out as metadata so that you can replay that over and over and iterate on it and then compare your learning curves and between the models. So the ML flow documentation, again, even if you decide to implement your own or go with another solution, it's really good at explaining the motivation and why you would do these things and the value that you get out of it.
Gotcha. Actually, going back to our previous question, another follow-up. So is it really powerful, unsupervised learning method at feature engineering, just only figure out data pattern?
I'm not sure I quite get the question, if it could be rephrased.
Ite, would it be helpful if I let you talk and ask the question live? Let me see. I'll ask you to unmute on my end.
So I'm reading the second part to this, and if I can rephrase it a bit. What you're getting at is if you don't have access to a domain expert, then is there an alternative that someone could use in order to start coming up with good features? This is really contingent on the data set itself. I mean, if you don't have a very large data set, then depending on the model that you're using, just use all the features. Like if you're using certain kinds of models like XGBoost or a random forest, I mean, these things have a tendency to sort of drop out features that are unimportant to the decision trees that it builds. So, you can use models that might be a little less sensitive to bad features that are being introduced. So it kind of depends.
Awesome. Yeah, no problem, Ite, certainly understand. I don't think I see any other questions. Certainly happy to stay on a few other minutes, additional couple minutes if anyone has any lingering questions. But yeah, like I mentioned, we have our third event in this knowledge series with another member from our SafeGraph team, Dr. Jeb Ho. Again, we're still finalizing the details on that event. So what we'll do is we'll take the attendees from this event and we'll follow up with you on those event details once those are confirmed. However, I did drop the link for the fireside chat that we have coming up. Certainly recommend that. Fireside chats that we host here at SafeGraph are always very engaging and super interactive. So highly recommend attending that one. Otherwise, I think we will wrap things up. Thank you, James, for hopping on today. And thank you everyone for joining us. We will talk to you soon, either in the SafeGraph community or at the next event. But yeah, have a great rest of the week and take care, everyone.
All right, thanks everybody.
Yep.